Today we're going to look at parallel and perpendicular lines. So this is going to require a bit of remembering Year 7. But we also refreshed it earlier this year when we did algebraic fractions. It's a word that begins with R and rhymes with reciprocal, and it is reciprocal. So let me just make the title here. Parallel and perpendicular lines. Alrighty, so when looking at these, we're going to need to remember a reciprocal. Now, you don't need to write this down in your notes. I'll just show you an example before we get started. So let's say we've got the number 3 over 2. The reciprocal of 3 over 2 is, flip the fraction, 2 over 3. Let's say we've got 4 over 7. That's going to become 7 over 4. Let's say we've got the number 3. Well, you need to remember that 3 is over 1. All whole numbers are over 1. So when we flip it, we get 1/3. We're going to be using that today, so just be keeping that in the back of your mind. Alrighty, so what determines whether a line is parallel or perpendicular to another line? It's actually to do with the slope. So if you think about this line here being parallel to this line here, they have the same slope. This one just hits the y-axis higher up than this one does. The same gradient or the same rise over run, if we remember that. So when we're looking at parallel lines, we're trying to look out for which lines have the same gradient. Now the formula we've been using is y equals mx plus c. And just have a think to yourself which part is the gradient before I tell you. Well, it's the m here. So this is the gradient. Just to refresh, that's the y-intercept. And as I said, we're looking for lines that have the same gradient to make sure that they are parallel. So let's quickly write that. Parallel lines have the same gradient as each other. Time for an example. So let's use black. AG. Let's say which of these lines are parallel to y equals 6x minus 2. Just give us maybe 3-4 lines. So let's say the first one, y equals 2x minus 6. Y equals 3x plus 1.5. C equals y equals 4 plus 6x. D, y equals 6x. And one more, why not? E, y equals 6x plus 8. Alright, so we need to figure out which of these are parallel to y equals 6x. The first step is we need to define the gradient of this line. So you can see here, the gradient is 6. It's the coefficient of the x value. So we're looking here, is there a 6 and is it the coefficient of the x? Well, here the gradient's 2, so not parallel. Part B, here the gradient's 3, so not parallel either. Here the gradient's 6. Now I drew this one out of order, just to make sure we're on the ball. It's the number in front of the x. It isn't the first number that we're concerned with, it's the coefficient of x. And so that one wasn't, but this one is. Alright, this one has no y-intercept. It does have a y-intercept, it's just 0. But we still look at the x term for the gradient, and it is 6, so this one is parallel. And lastly, this one here, again, gradient of 6, nice and normal one. So that is parallel. Alright, let's look at another kind of example. Let's say E dot G, find the equation of a line parallel to, this is going to be pretty tricky, but we've got all the building blocks to do it. Let's say 3x plus 2, that passes through the point. Let's say 4, negative 8. Alright, now, I'm going to draw this line first of all, just so we get a picture of what's going on, but it isn't actually necessary for our answer, but just so we got a quick sketch so we can figure out what's actually physically happening. So, first step, just like the last question, is we need to work out, well, if it's parallel to this line, the gradient is 3. So we need a gradient of 3. So it's going to be a pretty steep line. And it passes through a point 4 across, 8 down. So it's there. Just make it a bit bigger so it looks like I didn't miss. And there we go. Our line's going to be looking something like that. We're going to be trying to find an equation that fits that line. Now the y-intercept, you can see, is actually going to be pretty far down here. So we should have a large negative y value in our c value, sorry, for our y-intercept. Just a common sense check we can do at the end. Now we know this formula from a couple of lessons ago. Y minus y1 equals m x minus x1. And we call that the point gradient formula because you need a point with a y value and an x value and the gradient. And we actually have both of those things in this question. We've got the gradient of 3, because we know it needs to be parallel. And we've got x1, y1. So from here it's just substitution. X minus 4 in brackets, and over this side would be y minus negative 8, which ends up being positive 8. So I'm going to expand these brackets. 3x take away 12. And that becomes y plus 8. Then I'm going to take 8 off both sides. 3x minus 20. And there we go. Pretty far down here somewhere is our y-intercept. So we know that's making sense. Y equals 3x minus 20 is the line, the equation in this line that's parallel to y equals 3x plus 2 and passes through this point. Now, everything is the same for perpendicular lines. There's just one trick with the gradient. So two lines that are perpendicular have gradients that are, and here we go, this is where it gets tricky, negative reciprocals of each other. So I'll move that up here. Now, I was talking about reciprocals before, when you flip the fraction. For perpendicular lines, not only are we flipping the gradient, but we're also making it negative. Or, if it's negative, it's now becoming positive. So let's have a look at an example with this. E dot G. Find the lines perpendicular to y equals x over 4 minus 3. Alright. So we got y equals 4x plus 1, y equals 2, take away 4x. Let's say 4y plus x equals 3, and y equals 4x minus 1/4. Alright, a few tricks in here. First of all, our gradient. What number is in front of the x here? We know there's a 1 here, but we can't get rid of this bottom part of the number. That is all one term. So our gradient is 1/4. Alright. That's slightly off the page, sorry. Let me see if I can move that. There we go. Alright, so we need to find the negative reciprocal. So what happens when I flip 4 over 1? Well, I get, 1 over 4, I get 4 over 1, which is just 4. And I need the negative reciprocal, so negative 4. So this first line, 4x plus 1, it looked promising at the start, but we know it needs to be the negative reciprocal. So that gradient is not correct. Next one, y equals 2 minus 4x. Well, the gradient of this one is negative 4, so that one works out. This one here, I don't really know yet because it's not in the right form. I need it to be y equals mx plus c. So I need to rearrange this. I would take x away and then divide by the 4. So you'll see we get y equals 3 minus x, and both of those are divided by 4. Either way, it's negative 1/4, not negative 4. So it's not true. But we did have to rearrange, and if it's not in the form you want, you are going to have to rearrange it. And lastly here, 4x, negative 1/4, none of those are correct. So we've only got one this time. That was perpendicular. So I'm going to do a question that's pretty much exactly the same as that last parallel one we did, but this time we're going to be finding if it's perpendicular. So e.g., find the line perpendicular to y equals negative 2x plus 4 that passes through negative 1, 2. Alright, first of all, common sense check. Let's just graph it to see what we've got. Well, negative 2x is going to be coming down this way, and it's going to pass through at plus 4. So we want a line perpendicular to this that passes through negative 1, 2, about here. So we need pass through here and at 90 degrees. It's going to look roughly like that. Remember, 90 degrees in there for perpendicular. So we're looking for this line. If our equation is looking way different to that sketch, then we've probably made a mistake somewhere, and we can go back and check our working. Now, again, I'm finding the gradient. We've got m equals negative 2. I need to make a negative reciprocal of this. So 2, well, that becomes 1 over 2. And it already was negative, so I don't need to make negative here, because negative of a negative is a positive. So I use my point gradient formula. Should be remembering this one pretty well by now because we've used it quite a few times. So m is positive half x1 is -1 and y1 is +2. Let's expand x on 2 plus 1/2 y minus 2, and then we add 2. So x over 2 plus 5 over 2. And there we go, that is our line. You can see x is half, probably a bit shallower than I drew it, and probably a bit further down, but not too different. They're close enough that we're on the right track. Alright, I'll give you some questions to do on those that I'll check on Class Kick, and then you can get on with the textbook.